Good morning. Good morning to all of you. Yes, I think you are hearing my voice, audio, video also you are going to see. Okay, yes, just I will give you my introduction first, since it is the first class for you. Okay, I will give my introduction, then I will start. Then I will start the. Okay, see here, my introduction. Once the offline classes are started, we are going to meet. Okay, my name is Nagaraj Aras. Okay, this is my name. I have joined St. Philomena's College in the year 1991. 1991, I have joined Philomena's College. Up to 2014, I was there only. Still, I am there, of course. 2014, I have been deputed to, it is only a deputation. I have been deputed to Government First Grade College. Government First Grade College, Nanjangud. There I have been deputed and I took the charge as HOD of Physics and HOD of Chemistry. For about 6 years I served there, and now again I came back to Philomena's College. I came back to Philomena's College. Okay. But before this 1991, 1988, I worked for about 1 year at Marimalappa's College, PUC College. 1 year. 1989, I joined Uraja's College and I worked for about 2 years there, up to 91. 91, I have shifted from Uraja's College to Philomena's College. Okay. This is, of course, some disturbances there, that shadow and other things. Try to adjust. Try to adjust. Okay. Yes. During the morning session, that is, the shadow is coming up here. Yes, see here. I did my B.Sc at Uraja's College. Then MSc in Physics, Manas Gangotri. Then B.Ed in Government College of Education. M.Ed, Manas Gangotri. Then post-graduation in Diploma in Higher Education, IGNOU University. MPhil in Physics. MPhil in Physics and MA in Sociology in an open university. Okay, so therefore I did my MSc, one postgraduate, M.Ed, another post-graduation, MPhil, one more post-graduation, and MA, one more post-graduation, and post-graduation diploma in higher education. Okay, this is my qualification. I'm working at Philomena's College now. We are going to meet together once the lockdown, it has been open, everything is fine. Offline classes, once it is started, we are going to meet each other in the classrooms, either in the practicals or in the theory classes that we are going to meet. Okay, and in the beginning class only that I can say here, you can see my YouTube channel also. Some of the videos are uploaded in the YouTube channel last year only for the government college students. Okay, my YouTube channel. Okay, if you are typing like this, my name only, no problem, you will get it. You will get so many videos you are going to get, including your fourth semester, third semester, fifth semester, sixth semester, all the videos. Most of the videos are there. Still it is uploading, of course. Yes, this is my introduction. Now we will going to start the syllabus directly. Syllabus directly I will going to start. Okay. Yes. First idea, I supposed to start with the scalar field and vector field. And before taking up that idea, that first I will going to say that whatever the portions that I am going to take up is not so easy, a little bit difficult, electromagnetism. Okay, electrodynamics or electromagnetism, slightly difficult portion, slightly. Okay, but if you are obeying whatever I will going to say, if you are following my instructions properly, then you can secure in my particular portion 100% marks you can secure. Just like your mathematics, this is. Electrodynamics or electromagnetism, it is just like your mathematics portion. If you are writing completely, you will get full marks. If you don't write, you are losing 0. You are going to get 0 marks. You are losing every mark. Every mark you are going to lose. Okay, such a kind of syllabus this is. So therefore, right from the beginning, you start your studies. I will get you the notes. Through the online only, I will get you the notes. You take up the notes, read several number of times at home. Then instead of reading, I can suggest, take some sheets of paper, write and practice. It's completely mathematical notations, completely mathematical idea. Okay. So therefore, if you are reading, you will not understand. You have to write and practice. There is no other way. There is no shortcut method. You have to practice at home. How many number of times that you are practicing, that many times it will help you at the time of examination. Don't wait up to the examination. You have to start your studies now itself. Today itself you are supposed to start. My intention is all of you are supposed to secure very good marks. Especially in my portion, you are supposed to secure 100% marks. Completely. Whatever the questions, problem it has been asked, you are supposed to answer all those questions in a proper way. And you are supposed to secure a very good marks. So that is my intention. Okay, therefore, whichever the doubt that you are having, immediately you can ask. No problem, even in the next week also that you can ask. Okay, electromagnetic theory that I supposed to take up. Electromagnetic induction is easy. Electromagnetic theory is slightly difficult. But if you are practicing, then you are going to feel it after the examination. We were comfortable in that particular portion. We have secured very good marks in electromagnetism. Because of electromagnetism only, we got very good marks, you will say. So therefore, study well at home, right from the beginning. I will start the concept first. Okay. If you know the answers, you can unmute and you can go on answer it. What do you mean by a scalar quantity? Scalar quantity. What do you mean by a vector quantity? I will start with a very much basic concept. You have studied the scalar and vectors right from the beginning, from your high school level as well as in your first PUC level. Even in your first year PUC also, you have studied what are scalars, what are vectors. Scalars means what? What do you mean by a scalar quantity? Give an example. Anybody? Quickly, let us not waste the time. Unmute and answer. You can answer. Scalar means somebody, Sinchana. Okay. Scalar means it is having only the magnitude, sir, which is only the magnitude. So indirectly she said. So I will say directly, it has only the magnitude means which is not possessing the direction. A scalar quantity which possesses only, it is having only the magnitude. It is containing only the magnitude, which is not containing the direction, which is not containing this direction. Such a quantity is called by the name of scalar quantity. Such a quantity is called by the name of scalar quantity. Whereas a vector quantity means it is having both Magnitude, correct now? Okay, Bhumika, right? Magnitude as well as it is having direction. Okay, taken from your very much lower class. Okay, you most probably have taught all these things for your younger sisters or younger brothers. Okay, scalar quantity means is having only the magnitude which is not possessing the direction. A vector quantity which possesses both magnitude as well as direction it is containing. Therefore, it is a vector quantity. It's okay. Now, give some examples. Give some examples. Scalar quantity, example. You are answering. Okay, no problem. You are answering. Very good. Mass. Sinchana, mass. Okay. Volume. Mohammed. Volume. Padmini. Mass. Energy. Very good. Very good. What about vector quantity? Example for vector quantity. Force. Rukhya. Okay. Force. Sinchana. Velocity. Anybody else? 26 people are there. What about others? Displacement. Nice. Very good. Velocity. Nice. Displacement. What about distance? Distance. Displacement. Clear? Right. Displacement is a vector quantity, whereas distance is said to be the scalar quantity. But some occasion in electrostatics that we are taking, area is a scalar quantity, area vector that we are taking. Even from second PUC itself that we have started like that. Area vector. Gauss theorem, area vector. Okay. Line, length, line element is a scalar quantity. But line element if you are choosing, current element if you are choosing, it is a vector quantity. Current is a scalar quantity. Current is a scalar quantity. Current density is a vector quantity. Current density, I by A. I is a scalar quantity. I is a current. I by A is J. J is called by the name the vector quantity. You are going to study about the displacement current. Okay, this portion only. Here only you are going to study displacement current, J, J plus JD, everything that you are going to study. Slightly difficult. Right from the beginning, you attend all the classes. Okay, whatever the notes it has been going to give you, you study all the material every day. Every day. Studying means don't read it. You have to write several times. You have to write and practice. Okay, I don't want these ideas now because already you have studied about this. I suppose to consider scalar field. What do you mean by this scalar field? I suppose to explain. Scalar field means what? What do you mean by a vector field? Scalar field, and this is vector field. I suppose to explain. What do you mean by this scalar field and vector field? That is there in your syllabus. Scalar field is there, vector field is there. That is there in your syllabus. Okay, scalar field means what? A scalar field, it is a region. It is the surrounding, of course. It is a region or a surrounding in which a scalar quantities are varying from one point to another point. You said so many examples you have quoted here now, scalar quantity, all are taken from your maybe high school level physics, that is, high school level physics. At least think about the college level, PUC level physics, at least scalar quantity. Any other thing that you want to say? Let me see that. Okay, use your college level concept. Of course, whatever you have quoted the answers, scalar quantity examples, they are all right. Okay, but they are all below SSLC level, whatever the examples. At least above SSLC level, PUC level examples, at least you quoted. Whatever you have studied in your PUC level. Shall I use electric potential? Electric potential, is it a scalar or vector quantity? Answer it. Electric potential is a scalar or vector quantity. Electric potential is a scalar or vector quantity. Quickly. It is a scalar quantity. Electric potential is a scalar quantity. Clear? temperature, temperature gradient, they are all said to be the scalar quantity. Temperature is a scalar quantity. If you are taking a rod here like this is a rod. If you are heating the rod at one edge, one end of the rod if you are heating, then the temperature is varies from one particular region to another region. One point of the rod to another point of the rod. The temperature need not be the same because you are heating at one end. You are not heating throughout the rod. No, you are heating at one end here. Now, nearby that heating end, temperature is more. Away from that one, temperature is less. Called by the name the temperature gradient. Temperature gradient, that is. Temperature is varies from point to point in the case of a rod. Electric potential is also like that. For example, let us consider there is a charge here. Electrostatics, taken from your second PUC. Or even last semester you have studied about that, electric charges, electrostatics, Kelvin's electrometer. I don't know, I have not seen the syllabus of your last semester. Okay, this is Q, but university syllabus it says that last semester, third semester they have studied. Okay, I don't know for you people, I have to see that syllabus exactly. Okay, I have seen 4 semester syllabus only. This is Q. This is a charge. This is a charge. Surrounded by this one here, there is an electric field. Electric field is a vector quantity. Electric field is a vector quantity. Electric intensity is a vector quantity. Electric potential is a scalar quantity. Inside here, inside this region, electric field is there, electric potential is there. If you are choosing electric potential here, that electric potential at one point nearer to this one, 1 by 4 pi epsilon naught Q divided by R, you are aware of that, taken from your second PUC. 1 divided by 4 pi epsilon naught Q divided by R is the potential, electric potential. That potential is coming over here. If I'm choosing a point, here the potential is more. Here the potential is less. Here the potential still lesser. Outside this region, potential is equal to 0. So meaning, there is a charge. Charge is present here. Only one teacher is teaching to the whole classroom. But if you are conducting a test or examination, all the students, they are not going to secure 100 out of 100. I hope you understood. Varies from one student to another student. Because of so many facts and figures. Here, there is a charge. Surrounded by that one, there is a production of electric field. Inside that electric field region here, there is electric potential. But electric potential closer to the charge is more. The strength of the electric potential is more here because it is closer to the charge. The formula V is equal to 1 by 4 pi epsilon naught Q divided by R. R is the distance. Denominator is coming. The distance is coming in the denominator. Okay, follow this. So here R is the distance here now. If R is said to be the distance here, if R is less here, V is more. R is large here, V is less. Therefore, if I'm choosing a charge, surrounded by that one, there is a production of electric field. Electric potential is not a constant. Electric potential magnitude is changing from one point to another point. Electric potential at every point is not a constant. Electric potential is varies from one point to another point. That is called by the name a scalar field. This is a scalar field. Understood about the scalar field? A scalar field is the region. A scalar field is a region in which a scalar quantity which is varies from one point to another point. One point to the next point. That scalar quantity which does not remain same here, it varies from point to point here. Now, that particular region, that particular area or the region is called by the name of scalar field. Nothing else. That is a scalar field. Okay, follow this. Vector field is also like that. I have given another example here now. If you are choosing a rod, if you are choosing a rod here, this is a rod. If you are heating the rod at one edge, at one particular edge, if you are giving the heat energy, then at one particular point here, temperature is more here. Here the temperature is less. Here the temperature still it is less. Here the temperature still it is very small. So temperature along the length of the rod here, along the length of the rod, the temperature go on differs. It go on changes. The temperature of the rod from one point to another point, it is go on changing. This is called by the name scalar field, temperature gradient. The temperature varies from one point to another point along the heated rod. Of course, the heating, it has not been done at every point here now. The heating of the rod, it has been done. The heating of the rod, it has been done only at one edge. At one point only it has been done. Due to that heating effect at one edge here now, the temperature at all the points along the length of the rod, it is not a constant. It go on varies here now. That is called by the name a scalar field. I will make a conclusion now. What do you mean by a scalar field? Give example. Time to write for 2 marks. Now 2 marks question. What is a scalar field? Define scalar field. Give any one example or 2 examples. I will give it now. A scalar field is a region. A scalar field is a region in which a scalar quantity varies from one point to another point. Example number 1. The electric potential in a region surrounding a charge. The electric potential in a region surrounding a charge is a good example for scalar field. Number 2, point number 2. The temperature gradient, or I can say the temperature at various points along the heated rod. The temperature at various points of a rod, when it is heated at one end here now, then the temperature at every point of the rod need not be a constant. It go on varies from point to point here. That is also a good example for scalar field. Okay, understood? Now, second PUC has studied about the equipotential surface now. Equipotential surface. A very important 1 mark question that we have asked in the case of your PUC level. Equipotential surface. What do you mean by an equipotential surface? Give an example. Very important question for your second PUC. Here also it is holds good. Equipotential. It is a boundary. It is a region in which the potentials are equal. For example, this is a point. This is one more point at the same distance. Distance must be the same. Distance must be the same. If you are joining all these things now, it is an equipotential point. The points where the potentials are equal, and if it is locus of all these points, if you are taken, then you are going to get a particular region here, a particular sphere you are going to get. That is called by the name equipotential surface. These degree classes, it is called by the name level surface. Degree classes, it is called by the name level surface. It is called by the name the level surface. Example for level surface. Okay, equipotential surface. What do you mean by level surface? Join all those points which are all having the same amount of scalar quantity, then you will get a region. That region where we are getting the same quantity of the scalar quantity, scalar value, if it is existing, join all such points here now. That surface is called by the name a level surface. So an example for level surface, equipotential surface. Equipotential surface is a good example for level surface. Now again, go back to your second PUC level. Two equipotential surfaces, are they intersect? One more question. Taken from your second PUC. Two equipotential surfaces, are they intersect? If your answer is yes, you explain. If your answer is no, again you explain. For example, this is one equipotential surface. This is another potential. Maybe here the potential is 30 volts, 30 volts, 30 volts here, 30 volts. I have joined all such points. This is 30 volts point, 30 volt point. This is also 30 volts. This is 30 volts. This is 30 volts. This is 30 volts. Join all of them. It is equipotential surface. Degree classes is called by the name level surface. Another point. Here maybe 20 volts. This is 30. This is 30 volts. I have chosen another point here. It is having 20 volts. 20 volts point. One more point, 20 volts. One more 20. One more another 20 volts. 20 volts like this. All such 20 volts points you join like this. You will get another equipotential surface. This 20 volts equipotential surface is completely different. 30 volts equipotential surface is completely different. This equipotential surface and this equipotential surface, they are not intersecting. They are not intersecting. I hope you understood. They are not intersecting. Sir, if they are intersecting, what will happen? If they are intersecting, here 20 volts is there, here 20 volts is there, here 30 volts is there. If they are intersecting, at that point of intersection, that point is having 20 volts also. That's why I am explaining now. Sir, why can't the two equipotential surfaces are not intersecting? If they are intersecting, for example, if they are intersecting like this, this is 30 volts, this is 20 volts. How much is the potential here? You tell me that. This is 30 volts equipotential surface. This is 20 volts equipotential surface. At the point of intersection, how much is the potential? Umehani, answer it. This is 30 potential, 30 volts potential. This is 20 volts potential. This is 30 volts, 30 volts, 30 volts, 30 volts. This is 20, 20, 20, 20 like this. At the point of intersection, how much is the voltage is present? 30 or 20? Umehani, answer it. Don't know. Don't know. 30 also, 20 also. We cannot say. Therefore, the two electric potential surfaces, two equipotential surfaces, two level surfaces. Don't say it is destroyed that. No. Don't use the word destroyed. Oh, destroyed means potential itself is zero. Destroyed. Oh, it is. Corona is destroying the people. Correct now? No. Here it is not destroyed. So let us not use the words like that now. The physics words only that I had to use. Okay, we are not language people. So physics terms and technology only that we are supposed to use as terms. We have to use it carefully. Okay. The two equipotential surfaces, if they are meeting at the point of intersection, it is having the two potentials. 30 also, 20 also. If Umehani, if she is present for the class, if she is there in somewhere else also, okay, then cannot be possible. Either she must be present in the class or she must be present somewhere else in a marriage function. No, sir, I took my mobile phone in the marriage function only and I have switched on and I have kept it as it is. That is cheating. If it is an offline class, let me consider if it is an offline class. In the case of offline class, either she must be there inside the classroom or she must be there in the marriage function. Two things cannot be happening simultaneously. You have studied, I think, Pauli's exclusion principle, right? Electron, the position and momentum of an electron simultaneously, we could not be able to determine precisely. A person could not be able to occupy the two places simultaneously, correct now? A person could not be able to occupy the two places simultaneously. Here also, at the point of intersection, it is having 30 volts also, 20 volts also. It is having only one magnitude, sir. A scalar quantity means it is having only one magnitude. Either it is a 30 volts or it is 20 volts. Either it is 20 volts or it is 30 volts. Therefore, the two level surfaces, they are not intersecting. Cannot be possible. Understand about this? Two level surfaces, two equipotential surfaces, they never intersect. Understand properly. Actually, I'm supposed to explain del operator also. Let me see that if the time permits, I will take up that also. Otherwise, still we are there in the basic idea only. Coming to the vector field. Let me consider any vector field. Vector fields are electric field, not only sir, magnetic field, gravitational field. Whatever you have quoted the vector quantity, that's also right. But little bit higher standard that I am choosing here now. Electric field is a vector quantity. Magnetic field is also a vector quantity. Gravitational field is also a vector quantity. In these fields here now, electric field is not a constant everywhere. It go on varies from point to point. Magnetic field, if you are keeping a magnet, here, North Pole and South Pole, if you are keeping like this, surrounded by this one, there is a magnetic field. Everywhere magnetic field is not a constant. Nearby the magnet, magnetic field is more. Away from the magnet, magnetic field is less. As such a field is called by the name vector field. So what do you mean by vector field now? A vector field is a region. A vector field is a region in which a vector quantity varies from one point to another. A vector field is a region in which a vector quantity, which is that vector quantity? Either if it is an electric field quantity, if it is a magnetic field intensity, if it is a gravitational field intensity is not a constant. It go on, varies from one point to another point. So this is a vector field. Inside that vector field region, a vector quantity is not a constant. It go on, varies from one point to another point here. Now, such a field is called by the name vector field. Called by the name the vector field. Example: electric field, magnetic field, gravitational field. Follow this. And in your second PUC, you have studied about the electric flux, magnetic flux. Here we have chosen level surface. In the scalar field, we have chosen level surface. Example for level surface is equipotential surface. Two level surfaces are not intersecting. Two equipotential surfaces are not intersecting because at the point of intersection, which is containing the two scalar quantities, which is not possible. Impossible, I can say. It must be having any one quantity here at the point of intersection. Therefore, intersection cannot be takes place. Here, instead of level surfaces, we are going to consider flux lines. Here we have chosen, what is that? Level surface. An example for level surface is equipotential surface. Here it is a flux lines or flux curves. You have studied about the electric flux, magnetic flux, gravitational flux, everything. Flux means it is a flow. It is a Latin word. Flux, it is a Latin word. Meaning of flux means it is a flow. Flux of water means a good amount of water, if it is flowing, we can say a flux of water. It is a flux lines or lines of flux, lines of flow, we can say. So what do you mean by this flux? Okay, if I'm choosing an area here, this is an area. Through that area, how many number of maybe the lines, flux lines. This is flux line, this is flux line, this is flux line. If it is passes through the given area in a normal direction here, in a perpendicular direction, is called by the name flux density. It gives the magnitude of the vector field. So how to calculate the magnitude of the vector field? You determine the flux density, the magnitude of the vector field is given by flux density. What do you mean by flux density? Gravitational field, it should have some difference from one point. Yes, gravitational field, it is having a difference as you are go on moving. If this is the earth, if it is earth surface, above the earth surface, if you are go on moving here, gravitational field is go on decreasing on the surface of the earth, taken from your first PUC, even in first degree, of course, even in first year B.Sc also you have studied. On the surface of the earth, gravitational field of the earth is very large, 9.8 meter per second square, acceleration due to gravity. Okay, if you are moving away from the earth or if you are going inside the earth, acceleration due to gravity is go on decreasing. At one particular height, acceleration due to gravity is equal to 0. Okay, at the center of the earth also, acceleration due to gravity is equal to 0. You have studied all these things in your lower classes. Okay, coming back to the concept, magnitude of the vector field gives the flux density. Sir, what do you mean by this flux density? How many number of flux lines passes through the given area in a perpendicular direction to the area is called by the name of flux density. The number of flux lines. It is the number of flux lines. Number of flux lines passes through the given area in a normal direction. Is called by the name of flux density. Sir, you said flux only. How do you count the flux lines? Madam, better to go for your second PUC portion, read all the things. Electric flux theory is there, second PUC. Electric flux theory is there. You take up the portion of electric flux and read it. Okay, if I'm go on explain the second PUC portion, then electromagnetic theory I supposed to explain, not this flux. But I am explaining that also. But if you are choosing and asking about what is electric flux and how it is going to get defining, okay, then I have to take up the second PUC portion. E cos theta ds, E ds, general case, then special case, if the theta is equal to 0 degree, then cos theta is equal to cos 0 is equal to 1, then it is A into ds. It is, take your second PUC one booklet and read it. Okay. If I'm taking up all those things, then second PUC portion will be completing, not your fourth sem. Okay, you are aware of, you are not in the annual scheme, you are there in the semester scheme. Okay, within no time you are going to have the examinations. Within no time you will be having the examinations. Most probably May or June you will be having the examinations. Within that we are supposed to complete the portions also. So study well at home. The magnitude of the vector field is equal to flux density. Flux density means the number of electric line of forces if they are passes through the given area is called by the name of the electric field. The number of magnetic line of forces or passes is called by the name of the magnetic field. The number of gravitational lines of forces are passing is called by the name of the gravitational field. Take your second PUC book and read about the flux. Electric flux, magnetic flux is there. Chapters are there. You take your second PUC concepts and read it. Okay, this is about what is that? The electric flux or whatever it may be. But here, two level surfaces, they do not intersect. Here also, two flux lines, they could not be able to intersect. Two electric line of forces, they are not intersecting. Two magnetic line of forces do not intersecting. Two gravitational line of forces, again don't ask what is line of force. Okay, take your second PUC concept, one booklet you take it and read it. That is the basic. Even in SSLC I have seen 10th standard also there is electric flux. Okay, DC generator, AC generator, so many things are there even from 10th standard. Okay, what you have to do is you have to read from the beginning, from the basic you have to study. Then only you can understand. Okay. Yes. Coming to the concept, the two electric line of forces, the two magnetic line of forces, the two gravitational line of forces, the two flux lines, they are not intersecting. They are not intersecting. Sir, if they are intersecting, what will happen? If they are intersecting, they are having at the point of intersection, they are having two directions. But vector quantity is having only one direction. If it is having two directions, it's not called by the name the vector quantity. It is called by the name the tensors. Therefore, a vector quantity must be having one magnitude, one direction. A vector quantity must be having one magnitude, one direction at a particular point. A student must be having only one register number. I hope you understood. A person in India must be having only one Aadhaar number. I hope you understood. If they are having the two Aadhaar cards or two Aadhaar numbers, different Aadhaar numbers, then they will behind the bars. They are cheating the government. I hope you understood. Similarly here, if they are intersecting at the point of intersection, it is having the two magnitude and two directions. But a vector quantity must be having one magnitude and one direction, especially one direction it is contained. Therefore, two flux lines, they could not be able to intersect. They are not intersecting. Okay. This is this small quantity. What are scalar quantity? What are vector? Especially, what do you mean by scalar field? What do you mean by vector field? What are scalar field? What are vector field? Examples for the scalar field and example for the vector field. That's all I have explained. That's all I have explained. Now, I supposed to explain at least one more concept I have to explain. That is called by the name gradient of a scalar quantity. Gradient of a scalar function. All of you had to take one sheet of paper. You had to write all the concept along with me. Okay, simply if you are seeing, just like a movie, if you are seeing here, no use. You cannot understand. I told you today, beginning class only, I told you, portion of this particular one is not so easy. Okay, this portion especially, electromagnetic theory is not so easy. But easily you can secure the good marks. If you are practicing at home, you can secure very good marks here, very good marks. If you don't read it, easy to secure 0 also. 0 or 100. Okay, if you are practiced, 100. If you don't practice, 0. So that will happen here. Just like your mathematics, I said. It's mathematics only. Okay, higher end mathematics. Nothing else. But whatever you have not studied in your degree level mathematics, no, it's not. It is electrodynamics. Okay, coming to the concept. Gradient of a scalar function. What do you mean by gradient of a scalar function? I will consider a rectangular Cartesian coordinate system. You know about the rectangular Cartesian coordinate system. I will write it here. Just I will write XYZ axis, nothing else. This is XYZ axis. Okay. Vector theory, mathematics you have learned properly, is it right? If you know the vector theory, vector analysis under mathematics, physics will be very easy then. Okay, this is XYZ axis, X axis, Y axis, Z axis. This is origin. Okay, at the origin, I will going to consider a charge. I will keep a charge here. Is a charge, I will going to keep it. Maybe capital Q or small q, whatever you want, you write it. It is a charge, I have kept it here. Q is a charge. It has been placed. Where it has been placed? At the origin of a rectangular Cartesian coordinate system, X, Y, Z mutually perpendicular to each other. Okay, from first PUC analytical geometry, you have studied. From first PUC, still you are studying. Even in first degree, also you have studied. Final B.Sc also in physics that you are going to study. Q, relativity theory, we are supposed to take up all these things. So Q is present at the origin. Now, surrounded by this one here, there is an electric field. Surrounded by this one, there is an electric field. If you want, I will write that also. I will show it like this. This is electric field region. Okay, sphere. It is a spherical structure. Approximately, you consider it is a spherical structure. Electric field region is present like this. Inside that electric field region, I will consider a point here. I will consider a point. This point is said to be the A point, which is having a coordinates. This point is having a coordinate A, X, Y, Z. Small letters. Capital X, capital Y, capital Z. This coordinates. A coordinates are X, Y, Z. I will consider one more point here inside the electric field region only. I will consider another point here. That is B point here, whose coordinates are X plus dx. Small change is there in the coordinates. Y plus dy and Z plus dz. These are the coordinates of the point B. These are the coordinates of the point A. Clear? Now at the point A, potential is equal to U. U be the potential at A, then U plus du is the potential at B. U plus du is the potential at B. If I am drawing a line from here to here, this is your position vector. I will take this one as dr. Dr is the position vector. I hope you understood now. Now I will write only that A, B, dr, U and U plus du so that you can understand in another diagram like this. This is the point. This point is A, X, Y, Z. This is one more point, B, whose coordinates are X plus dx, Y plus dy and Z plus dz. This is the B point. At the point A, potential is equal to U. At the point B, potential is U plus du. Or even U minus U. A small difference is there, I suppose to take up. The distance between here to here is dr. For the examination, this is enough. Okay. Dr. Dr is a displacement or position vector you can consider. Right. Now I will write, if you want, I will write here now dr. Sir, what do you mean by this dr? Dr is the displacement. What is the du? Here to here, du. U plus du. U plus du. Du is equal to change in potential. Change in potential. Now I suppose to define gradient of a vector. To define the gradient of a vector, first I will take up the rectangular Cartesian coordinate system. Using that, I will write it like this. Dr vector can be written as, taken from your lower classes, first year degree portion. Vector analysis. I cap is a unit vector. I is a unit vector along the x-axis. J is the unit vector along the y-axis. K is the unit vector along. Okay, if you want, I will show it like this. This is a unit vector I cap. This is the unit vector j cap. This is the unit vector k cap. I, j, k are the unit vectors along x-axis, y-axis and z-axis. So therefore, dr is equal to I cap into dx plus j cap into dy plus k cap into dz. Sir, how we got this one? This is from rectangular Cartesian coordinate system. This is from rectangular coordinates. Okay. Now I will take up the Taylor's theorem. Using the Taylor's theorem, I will write du is equal to how much? Du is equal to, carefully have to think, del u divided by partial derivative, del u by del x into dx, carefully have to write, plus del u by del y. Now the problem starts already for some of you. So carefully have to think, have to practice at home, into dy plus del u by del z into dz. This is from where we got it here now. This is from Taylor's theorem. This is from Taylor's theorem. But definition part, it says that u dot dr, it is a dot product, scalar product. U dot dr is equal to du. This is by the definition. This is called by the name the gradient of u. This is called by the name gradient of u. This one only I supposed to explain. This is definition part. U dot dr is equal to gradient of u. See that? I will show the whole thing. Yes. Another 2 more lines that I will write. Then I will stop and I will ask you. As soon as if you are coming to the offline classes, test will be there. Get ready. As soon as if you are coming for the offline classes, I will conduct the test on all these concepts. All of you to take the test. Okay, it will be included for your internal assessment. IA marks. So study well at home. Because I know that if you don't study at home, all these ideas are not so easy to secure the good marks. If you are reading well at home, all these ideas are very easy to score the marks at the time of examination. So what I am doing is forcibly I will make you to study, no other way. If you are studying by yourself, no problem at all. You have to write. Along with me, you are supposed to write. Of course, afterwards I will send the notes. Before sending the notes, you must be reading now. You have to. Instead of reading, you have to write and practice. Okay, u dot dr, by the definition part, u dot dr is equal to du, gradient of u. Now I will take up u. Dr already we are aware of this. I will substitute that one. Okay, so by the definition we got this one. U dot dr is equal to du. This is by definition. I said. Now substitution we are supposed to do. U, as it is I will write, into dr is equal to how much? Dr is present here now. I will substitute that. I cap unit vector dx, j cap dy, k cap dz is equal to du value I will substitute is equal to del u, this is from Taylor's theorem, del u by del x into dx, del u by del y into dy plus del u by del z into dz. Clear? Follow this. Now, therefore, u is equal to how much? Therefore, u is equal to how much? Dx, dx, dy, dy get cancelled, of course. I cap goes here now. 1 divided by I cap is I cap only actually. I cap is a unit vector. I cap del u by del x plus j cap del u by del y plus k cap del u by del z. This is called by the name grad u. It is also called by the name the grad u. This is a definition for grad u. Therefore, grad u is equal to, this is called by the name the grad u. Grad u is equal to I cap del u by del x plus j cap del u by del y plus k cap del u by del z. This is grad function. Okay, only one small concept that I have covered. Actually, I supposed to explain del operator also, but time does not permit. Okay. Just to go through all these things at your home, take one sheet of paper, write, and practice. Umehani, you are going to get physical significance, grad, dive, curl, dive, okay, gradient of a vector, everything you are going to study, problems also you are going to study, don't be hurry. Okay, one by one, we have to take up. Okay, next class you are going to study about that. Okay, using the grad function only that we are going to take up the del operators. After the del operators, we are supposed to consider practically that one only. Okay, electric field, if you want to determine how much it is said to be existing at a particular point, we require this. Okay, without these mathematical concepts, we cannot determine how much is the electric field, how much is the magnetic field. Okay, not only that, how much is the water if it is flowing through a given area in a given volume, that can be determined using the curl. Okay, whether it is a sink or a source, that we can determine by using the curl idea. Curl means what is that? You are going to study in detail. Okay, yes. One more minute time is there before 10:30. Go through all these things. Study well at home.